In this video, you will gain an understanding of capacitive proximity sensors. You will delve into what they are, explore their main components, uncover their working principle, examine their sensing range, discuss the materials they can detect, explore mounting styles, cover the sensor wiring configurations, and finally, explore the diverse applications where these sensors shine. Stay tuned for a deep dive into the world of capacitive proximity sensors. Imagine a sensor that detects objects without even touching them. That's the brilliance of a capacitive sensor, converting subtle movements or the presence of objects into clear electrical signals. Let's look at the four main components of capacitive sensors. First is the sensor's body, which houses the essential internal circuitry that causes the sensor to function correctly. This body is made from corrosion-resistant plastic for longevity. The second component is the sensing phase. It is responsible for sensing objects by emitting an oscillating field. The third part is the indicator light, located opposite the sensing phase. It illuminates when a target is within range and switches off when the object moves away. The last part is the connection interface that offers versatility. Some sensors come with a cable already attached, complete with all the wires you need. Others have the added convenience of a pre-installed cord set or a built-in pin connector, so you can easily screw the cable in for a quick and easy setup. Let's dive into the working principle of capacitive proximity sensors. The sensing head of a capacitive proximity sensor contains two parallel dielectric plates functioning as an open capacitor with a specific capacitance. The oscillator circuit sends a voltage to a capacitor plate, generating an electrostatic field from the sensor's sensing end. Simultaneously, the sensor's detector circuit relies on the oscillator's output frequency as its reference. When an object comes near the capacitive sensor and interrupts its sensing field, it first increases the capacitance. This increase leads to a higher oscillator amplitude of the oscillator circuit. The detector circuit then notices this frequency change and responds, such as turning on the sensor's output when the detected change is substantial. Capacitive sensors distinguish themselves from many other sensing technologies by their proficiency in detecting diverse materials, including metals, wood, plastics, glass, fabric, leather, rubber, and more. Also, they are adept at identifying liquids such as water, paint, and oil. Another fact about capacitive proximity sensors is that they can effortlessly penetrate non-metallic barriers to detect materials within tubing and containers. By capitalizing on the contrasting dielectric constants between the substance and its container, these sensors pave the way for seamless material sensing. Let's explore the sensing range of a capacitive sensor, which signifies the furthest point from the sensor's face at which the target is detectable. For optimal performance in various applications, some capacitive sensors feature adjustable controls for sensitivity. When you turn the screw counterclockwise, the sensitivity decreases, suitable for detecting objects nearby. When you turn the screw clockwise, the sensor's sensitivity increases, allowing it to detect objects at farther distances. You can check the datasheet or manufacturer's website to see the sensing range of your capacitive proximity sensor. A capacitive proximity sensor cable contains 4 wires: brown, blue, black, and white. Brown and blue wires are the power wires and need to be connected to the power supply's positive and negative terminals. The black and white wires are used for the sensor's output signals. When the sensor detects a target, it sends a signal through the black wire, the normally open output. If no target is detected, this signal stops. Meanwhile, the white wire, the normally closed output, sends a signal when there is no object nearby and stops when an object is found. You can find capacitive sensors in various configurations, which may output a positive signal, PNP, or a negative signal, NPN. PNP sensors send a positive voltage upon detection, while NPN sensors connect to the ground. The connection setup will determine which sensor output style is needed. If you are not familiar with PNP and NPN terms or want a deeper understanding of each sensor type, fear not. We have created separate videos specifically covering NPN and PNP sensors. Check them out for a more comprehensive grasp of how these sensors function and their applications. Links to both videos are in the description below. Mounting a capacitive sensor can be entirely straightforward. However, the ease of installation largely hinges on its intended application and specific placement. Some sensor variations offer a seamless installation experience readily adaptable to various surfaces with the easy use of bolts. Conversely, other sensor styles may demand a more hands-on approach, requiring drilling and tapping a precise hole to accommodate their dimensions accurately. For instances demanding adaptability and stability, the strategic use of a bracket often emerges as the most viable mounting solution. Let's delve into the setup of a capacitive proximity sensor for liquid detection in a non-metallic container. Once installed next to the container, notice the sensor's indicator light activation, indicating high sensitivity and requiring adjustment. Adjust sensitivity by turning the screw counterclockwise until the light deactivates. Fill the container with liquid to the sensor level, then clockwise adjust the screw until the light illuminates. Confirm the setup's success by reducing the liquid level below the sensor, causing the light to deactivate. Capacitive proximity sensors are crucial in the industry for non-contact detection of objects and materials, enhancing automation and safety. The following examples will illustrate their applications in various industrial processes. First on the list is part detection. Capacitive proximity sensors are designed to identify objects on workstations and robots. Upon detection, these sensors transmit a signal informing a workstation or robot that the part is ready to be picked up. Employing capacitive proximity sensors allows for precise part counting. When strategically mounted along a conveyor system, these sensors seamlessly activate a counter mechanism to track the number of parts produced. Using capacitive proximity sensors to measure liquid levels in non-metallic containers ensures proper monitoring. These sensors can identify whether the fluid levels in a tank are high or low and will activate alarms to notify operators of the current conditions. Your input shapes our content. Let us know what topics in industrial automation you want us to cover in the comments section. Also, if you found this video helpful, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out-of-the-oven videos. This way, you keep motivating us to produce more informative videos.